Hello there, this side Aditya Ranjan. In this video, I will demonstrate the functionality and inner workings of a high-performance cryptocurrency matching engine built in C++. It is inspired by the design principles of REG NMS and built for speed, reliability, and real-time trading. So first of all, we need to install the dependencies that's mentioned in the documentation. But I have installed the dependencies, so we will directly start with the build process. So this is the build command, and with some warnings, our engine is ready now. So let's run our engine, and we will use Postman for API testing. We will send some mock submit order request, and then we will see how our engine is processing the request. So the engine is running. Now open Postman to test the APIs. We have three tabs. One is for a limit type buy order, another is for a limit type sell order, and the third one is for getting the trades update. So first of all, let us subscribe the trades channel, connect to the server, connected, and then send. You can see subscribed channel trades. Let's now send the limit type buy order, connect, send. Order accepted. Now send the limit type sell order, connect, send. Okay. Now here we have got the trade update. This was for $30,000, 0.9 unit Bitcoin. This was also $30,000 for 0.9 Bitcoin. And in the trades, you can see a trade with ID 1 has been executed for $30,000 and 0.9 quantity Bitcoin. So in this way, our engine works. Hello. We can also subscribe to the real-time market data to get the update whenever a trade is executed. The engine will send the real-time market data to the subscriber. See, subscribed market data. Now, if the trade is executed, then we will get two responses: the trade report and the market data. Send, send. See, this is of the market data. Like currently, after the trade has been executed, there are no asks and there are no bids, and it is the trade response that a trade of with ID trade ID 2 is executed for price $30,000 and for 0.9 Bitcoin. The core of this engine is the matching algorithm inside the order book class. We maintain buy orders in descending map and sell orders in ascending map, both using sets to preserve FIFO, that is first in first out, or we can say first come first serve at each price level. Here you can see the bids are stored in descending order and the asks are stored in ascending order. This structure ensures the price time priority, the core principle of REG NMS compliance. When an order arrives, it tries to match against the opposite side. If a match is found, we execute a trade at the maker's price. Here we can see the match order function, which is using a switch case to check for the order type and execute accordingly. Then it is the execute market order function, which checks for the type of the order. That is, if it's buy, then it will search in the ask map, and if it's a sell type order, then it will search in the bids map for the best order to trade with. Talking about the key data structures, so each order stores essential metadata like symbol, type, side, price and quantity, and timestamp. The trade struct captures the details of each executed match like trade ID, price, quantity, and who initiated it. And the crypto matching engine acts as the coordinator, routing orders to the correct order book and managing callbacks. Here are some logs in the terminal which I inserted during the development, but I forgot to comment it out. I will close the engine, and when it closes, it gives the performance statistics, that is number of trades executed and the number of orders submitted. So all the orders were in Bitcoin to USDT symbol. So this has a count of 4 and rest are 0. Now let's talk about the design decisions. I used C++ for performance, leveraging STL containers for reliability and safety. Instead of complex lock-free code, I use shared mutex for reader-writer access. It's fast and simpler to manage. Orders are sent and received over WebSocket using JSON, human readable and easy to debug in the future. We could switch to binary protocols for even lower latency in future. The matching engine is designed around REG NMS principles. It always executes at the best price available and honors strict FIFO rules. For fair execution, no trade throughs are allowed. Price improvement is always applied. Like here you can see in the code, and there are four types of order in our engine. So we have four different functions for handling the four different orders. Execute market order, execute limit order, execute IOC order, and execute FOK order. So these four functions manage the four types of orders in our engine. The engine includes a complete test suite covering limit, market, IOC, and FOK orders, as well as concurrency and performance test. In benchmarks, it processes around 5 lakhs to 7 lakhs orders per second, proving its readiness for high frequency trading. We can run the test by running the command test. So here it runs the unit tests. Here you can see the result of the unit tests. It checks for all the four types of orders. It also checks if the price time priority rule is followed or not. It also checks the order book. It also checks for the concurrent orders. The time taken was 16 milliseconds and the performance we can calculate on these metrics is around 6,25,000 orders per second. So it easily crosses the target of 1000 orders per second. This crypto matching engine balances speed, safety, and simplicity. With modern C++, WebSocket API, and robust design, it forms a strong foundation for a scalable trading infrastructure. So here is the build command that we can also find in the README file or in the documentation. So using these commands, the engine can easily be built and can be run easily. So that's all from my side. Thank you for watching. I am hoping for a positive response. Thank you.